Hi there, I'm going to show you a brief clip of me struggling to knit, and we will soon get into why this is related to the topic of neuroplasticity. Let's start off with a brief introduction to one of our brain cells, or our neurons, and how they function. One end will be the site of release, and the other end will be the site for receiving molecules. We see that at the front of the neuron, the blue circles will be received by the neuron. At the other end, the neuron will release these red circles into the environment or the inside of our brain. Now, I want to show you what is going on inside my brain when I am learning to knit. First, we have a dormant brain cell, meaning it is not being used or hasn't been used in a while. But once I start to knit, these signaling molecules, which are represented by the blue circles, will start to travel from one neuron to another. And that dormant neuron now becomes active since it is working to transport those signaling molecules again. So, what is this phenomenon called of making new connections between neurons? Well, it's actually called neuroplasticity. Neuroplasticity is the ability of our neurons to rewire or reorganize themselves. And now, after some neuroplasticity and practice, since practice is what strengthens that new connection between the neurons, I can now knit somewhat faster and better than what I could before. So now, let's compare two situations that occur in the human brain. One is the normal situation in which the signaling molecules will be in the space between the two neurons and will easily be taken up by the neuron next to it. Then we have another situation which appears to be normal but is not, and we will see why in just 1 second. For the normal situation, the signaling molecules will easily flow between two neurons and will make these new connections. On the other hand, we have the second neuron that will not want to receive these signaling molecules. This will cause the death of the neuron, which is known as neurodegeneration. But what if we were to have another case in which there is a neighboring neuron that will accept these signaling molecules? Well, if you thought that the neighboring neuron would take in those signaling molecules, then you are correct. This neuron will take in those signaling molecules and form a new connection with that neuron, and that is known again as neuroplasticity. But now you may be thinking, well, why would that last situation even occur? Well, that last situation is actually what occurs when someone has Parkinson's disease. The neurons will start to die because they can no longer receive a certain signaling molecule. But with neuroplasticity, people suffering from Parkinson's disease can form new connections between different brain cells and therefore minimize the effects of this disease, such as the loss of movement. In this video, I demonstrated how neuroplasticity can be applied to a variety of situations, whether that is learning how to knit, learning that new soup recipe, or learning how to type on a computer. Neuroplasticity is constantly happening around us, and with that I say thank you for watching.